anything doubt or anything, please feel free me to stop at any time and then you can ask. If my slides are not visible or if I have some problem with my audio or anything, please interact with me. I mean, if I ask any questions, try to interact with me so I can understand that the connection is established. Fine. So this is the outline of the today's session. Before going to say about what is deep learning and other things, I'll just start with the association of deep learning with artificial intelligence. Then we will see about how the machine learning comes into picture. Then slowly we'll enter into the deep learning, why we want to do the deep learning, and we'll discuss about some of the applications of deep learning. And finally, I'll conclude this presentation. So this is a very important slide. So this talks about the boom of artificial intelligence, or this is a R&D timetable of artificial intelligence. If you clearly see this table or this figure, we see that the first computer starts in 46. ENIAC is in 1946. 1947, Alan Turing proposing the concept of AI. So I hope you are aware about Alan Turing, famous mathematician. With his name only, we are using a Turing machine, Turing test, even Turing award, and all other things. So 1946 is the first computer, and 47 AI comes. So AI is as old as computers. So this concept, initially when it comes, the researcher or scientists are believed that AI is going to solve all the problems. So they initially realized that this AI or the computers, whatever that generation model, is a kind of opposite to the natural intelligence, artificial intelligence. But slowly, if you see that, so people, that was the first boom of AI, but slowly the popularity goes down because rather people understand that there is something called NP-hard problem, even a computer cannot solve, and the present AI systems cannot solve few problems. So people understood that, so the popularity of AI goes down. Again, the popularity of AI goes up when the Kunikiho, so from Japan, he introduced the concept SVM, or sorry, not SVM, neural networks. In 80s, is a second boom of AI where neural networks comes into picture. So now how we are talking about AI. So like that, the 80s also the same situation. All the researchers are moving towards AI, started applying neural networks. After that also people identify some issues in a neural network models, some challenges, and it's not improving further. So the popularity goes down. So in between, there is something called kernel machine, SVM. So that also brings a popularity to AI for a certain time period. And now, 2006, now means a 15 years back, 2006. So the popular paper by the person Hinton. So you can say he's a father of deep learning, Hinton. So he come up with the paper in 2006 about deep learning. That's a first breakthrough towards a deep learning. It's a very simple research paper, talks about automatic learning of the representation. So that brings a new boom to the complete AI system. So from that time onwards, the AI popularity is increasing till the last 15 years. If you see that, last 15 years, the AI, not only the AI, the deep learning and AI rules the world. So we are expecting in future also. Future means next 10 years or next 15 years. So people definitely the AI will exist. The best example, if you see that currently, if you see that there's something called each time whenever that new technology comes, so how the academic institution or how the academia reacted to that. If you closely see that, how we are reacting to that, the particular change, the technological change or new invention or new technology comes. So now, particularly in this current last few years, if you see that, Everywhere people are having a starting a course on AI. Even we have a course on BTech AI, and so many other institutions have the course on BE or BTech in computer science, specialized with AI. That's the one thing I'm saying AI actually. So like so many things are there. Like IoT also nowadays the courses comes. Fine. But if you see that the popularity of AI so brings to the next level. So people are introducing the course. Future we may expect the government may come up with the institute for AI. So chances are there. So this shows the popularity of this clearly shows the popularity of AI among the academic institutions or academia. Industry side, if you see that most of their projects they already started shifting from other techniques to AI. So whatever projects they are working or they are doing, so they are incorporating this AI component. Even it's a R&D, it's fine. They are started incorporating. Earlier, very few companies only concentrate on R&D. They will concentrate on most of the companies will go behind the product development. Now, because of AI, even a startup have the wing of R&D wing where they want to incorporate AI and then they want to see that how the products are improving further. Fine. So now, when it comes to the relationship between the deep learning and machine learning with respect to AI is a bigger circle. So the subtype of AI is machine learning. Subtype of machine learning or subset of the machine learning is deep learning. So this is with respect to time. So AI started in 50s. Still it rules the world. So machine learning in between comes and then it gives the boom and deep learning. Now AI goes to the next boom. Here people are calling it as a explainable AI. That's the next boom of AI. So when it comes to the applications of with respect to AI, why AI or why deep learning models? So we cannot restrict. If you say any other domain, if you are taking, so you can restrict yourself. These are the application. These are the application areas or these are application domains. You can say, but here you cannot say. Wherever data is there, you can apply AI models. So lawyers are using AI, doctors are using AI. So now you just think about. So any domain, so not necessarily comes under engineering or technology, any domain, anyway, if you have some enough data, definitely you can use AI or deep learning models. So AI is emerged as a separate field, separate domain. So soon it's so now itself we see that as the department comes, the AI comes out of computer science. AI is emerged as a separate domain. Another point I want to share actually, if you closely see that, particularly the computer science and IT. So earlier in 80s, people used to say that computers means it's only the computer science and IT. So you in 90s or in okay in not only 90s in 2000 also if you see that you may not see computers in other departments. So I'll just talk about only the academia here. So can you in 20 years back there may be only one system in complete mechanical department, right? Now is it a case similar case? No, right? So the computers earlier we said that the computer CSIT people said that computer science computers means it belong to us. Slowly computers occupied everywhere. Now you cannot climb, right? Now can you climb that computers means only computer science should use one you guys are using? Computers is a common machine now, it's a generalized one. Computers. So slowly computers left from our hand. The next one is a programming. Programming also the same way. So earlier programming means if you see that it's computer science or IT. So long back people started using programming. Doctors are learning Python. Lawyers are also learning. So I'm just talking about a different field, lawyers and doctors, and then you should not ask about other domain like civil or other streams like a civil or mechanical, right? So programming also goes out of our hand. Now you cannot climb. Oh, no. If you want to learn programming, you have to join computer science course or something. 6th standard students, kids are started learning programming, right? We are seeing advertisements. Fine. Programming also goes out of our hand. The third important one is actually now recently goes out of our hand is artificial intelligence. So as it was the earlier it was a domain of computer science or IT, now it's emerged as a separate domain. So what will be the future of computer science? Any guest participants? What else we are going to give to the other streams? Participants, am I audible, right? Hello. Can
Yes, sir.
anyone say that? Yeah, please. Can anyone say
Yeah,
that what's the future of computer science or IT? So I read an article that now everywhere the engineering admissions are going on. So one south state is increased 50% of computer science IT related seats this time. 50% in a year. So see that you cannot imagine. 50% seat means already 50,000 seats means now they're adding 25,000 seats and then it becomes 75,000. So where it will going to end? The question. Any answer?
automation, sir.
Automation. Okay.
It's generalized one we can apply for anywhere at any time.
Yes, ma'am. It's the next one. So my question here is where it will stop actually, where it will end.
When there is no need of human interaction.
Okay. So you mean to say that you are building you are building the
Yes,
machines, right?
yes, yes,
You are
sir.
completed.
Independent of humans. Yes.
Fine. So that time we don't want computer science itself. So the future there won't be any computer science, but everywhere computer science will be there. So mechanical with computer science, something like that, mechanical with computing, civil with computing. So doctors also going to learn the whole computer science course, something like that. It may be the future. So it's look like it's not there, but everywhere it will be there. Fine. So that's a power of artificial intelligence. Now we are going to see the difference between the machine learning and deep learning. So now I'm just asking some of you guys to say about what is meant by machine learning. What is your so if I know your understanding level of machine learning, it's easy for me to start the deep learning. Yeah, please. What is machine learning? It's a kind of
We make
discussion. Yeah,
machines to decide themselves.
you make machine to decide. Okay,
Yeah,
fine,
to
themselves.
act like humans. Yes.
Fine. So you are building a human artificial brain, right? Fine. Any other definitions?
Yes, sir. Am I audible?
Yes, ma'am, you are audible.
Hello.
Hello, yes, you are
Hello,
audible.
sir.
I can hear you,
Yeah,
ma'am.
machine learning is like, yeah.
Please.
Yes, sir. Learning is like from the past experience, we will have some past data. We train the machines according to the past data, and we make the machines to work without being explicit program in the future. So the machine will decide of its own and make decisions. So this is
Yeah,
what ML is.
yeah. Thank you. Thank you for your detailed answer, and then you covered most of the things. So that is the
Yeah,
exact
thank you.
definition of machine learning. So we are going to teach a machine based on the experience. Here the experience is the data, whatever data we have in previously. So yesterday's data, day before yesterday's data, or the complete data, whatever you are having, you are going to feed to the machine to teach the machine to take some decisions. Say for example, now we have a human. Say for example, you have images. A job is given to you. You have an image, so you need to decide that. So I'm poor in drawing. So you need to decide that whether you need to find out whether the image consists of dog or not. So I'm going to give a 50 images to you. To find out, you need to say that whether this image consists of dog or not. I'm giving 50 images to you. You need to make a folder. If an image is having a dog, you have to copy it to this folder. That's a job given to you. First work, as I said, that 50 images I am giving. So definitely you will do, right? 50 images I'm giving. 100 images. Yeah, you will do it. 500 images. So it will take some time, but we can do 500 images. Each image I'm seeing, I'm checking whether dog is there or not. I'm doing 5 crore images I'm giving. A human can do that job. One person I'm talking, but a machine can do. A machine learning can do. Even though not more than 5 crore data for more than 5 crore images, if you are going to the machine will do it in immediately within a few minutes. It will say that this many images are having dog. These are the dog images. These are images we doesn't have dog. That's the power of machine learning. So how the machine learned now? How a machine knows the images consist of dog or not? Now the question comes to you. If you closely see that machine learning or deep learning architectures or algorithms, all the algorithms, I can say that instead of most, all are inspired based on human brain. How our brain works. Because obviously, right, you know something called natural intelligence. You are building artificial intelligence system. So first you should know how the natural intelligence is working, right? So now how the natural intelligence is working, how you know that the image is having dog. Suppose I'm giving an image to you, participants. You are saying that the images consist of dog or not. How you know that? How your brain identifies that? Quick answer, participants. How your brain identifies that the particular image consists of dog or not? Please.
Hello, am I audible,
Yeah.
sir?
Yes, ma'am.
Yeah, our brain classifies the image based upon the features.
Based upon the
Yeah, features which we see.
features. Okay. Hello.
Yeah,
So based
that's
on the
why
features. So what is the how your brain knows about the features?
already it's recorded in our brain. No, like cat will be like this, dog will be like this. So when we see the features like hair or whatever its outer structure appearance, so our brain automatically
So
decides and
you
categorizes
already,
it.
it means that to say that you already know what is dog, what is cat, right? Suppose we are
Yeah,
bringing a person from Mars tomorrow who doesn't see dog. First time you are showing the photo, whether a person can distinguish that? Definitely no, right? The reason
yeah,
is you how you know that it's a dog because you already seen dog. You have your brain is trained. Your brain is now the machine learning model. You have seen dog images. You have seen 1 lakh dog images from your childhood. I'm saying example. All the dog images are recorded in your brain, stored in your brain. Dog images means the texture features, how the dog look like. So that information. Even if you are not seeing the dog, I'm giving only the half of the dog. I'm giving only the tail part of the dog I'm showing. You can say that it's a dog, right? Because your brain is learned such a way that pieces of information, it's stored, recorded pieces of hierarchical information. Your brain stored that way that. So you even though if you're showing that, if I'm showing the little bit of dog, you can say that this is a dog. Even if I'm not showing the complete dog picture. Same way machine also I'm going to train. So I know that how your brain trains. So you have seen a lot of images, right? So like that, I'm going to show the images to my machine. And each images I'm going to tell my machine, this is dog, this is dog, this is dog. So this is a kind of supervised learning. So I'm giving the images, I'm giving that labels. Labels is dog or not. I'm giving the images. So the machine is learned from that. So if you give a new image to the machine, so machine will understand that whether it's a dog or a cat, something like that. So that is a process of machine learning. Fine. So now when it comes to the deep learning, so in even though the machine learning, one point I have missed in the machine learning. So I'm giving an input and then the machine is telling that whether it's a cat or not cat or dog or not dog. Fine. But how a machine learning will understand the image? So what we cannot give the image directly to the input of the machine learning model, because machine learning models are mathematical model. So it works with the numbers. It's a mathematical model. It's doing some optimization. It's doing some calculus, right? It's not more than that. It's doing majority things are optimization, calculus, and linear algebra. It's doing some optimization. So all the mathematical models, you know that it's a number based one, because the image you are giving, right? So it won't consider it as a numbers. So we need a human intervention to convert that into meaningful numbers or meaningful features. So the feature extraction guy who is sitting here as a human expertise, he is telling that to the machine. So I'll help you to understand that if any image is given, you find out whether that particular image is. Yes, I'm audible, right? Hello, ma'am, I'm audible. Shall I continue?
Yeah, yes, sir, audible, sir.
Fine. Okay, thank you. Some disturbance, that's what I thought. Okay. So if I giving the image, the human intervention means the human is telling that you check whether it's having tail or not. You check the tail length, you check the face, you check the face shape, you check the length of its legs, you check the number of legs, you check the body shape, something like that. So these are the features that I'm giving to the machine learning model. So machine learning will look onto that only that features. It will take the tail length, it will take the face features, it will take the number of legs, leg shape or leg features, it will take. From that it will decide that whether it's a cat or dog. So you are helping the machine learning model. That's a human intervention or feature extraction. As machine learning model is not intelligent, as machine learning model doesn't have intelligence to extract the features, you are extracting the features and then you are giving. It's a usual traditional machine learning model. But in case of deep learning, we don't want feature extraction by human. So we are giving that to the machine learning itself. So machine learning will take care of feature extraction and classification. Sorry, not machine learning, deep learning. The algorithms will take care of both. The earlier machine learning model, I need someone to extract the features. But now, whatever model we are using, CNN, RNN, LSTM, all the deep learning models, you no need to give any features, any explicit features, any handwritten features, or any handcrafted features. You are giving enough data to the model. So model will learn the features by its own way. Based on the features, it will do the classification. That's the main difference between machine learning and deep learning. Where we can apply machine learning, where we can apply deep learning. If you have a small data set, you can go for machine learning. If you have a huge data, massive data set, you can go for deep learning. So it's a quick to train the model. It's computationally intensive. Sometimes you require a GPU, or sometimes you require a cloud GPU or GPU system. So the features, so that the features, you need to try a different features. I don't know which features will work. We have to try the features and we have to find out. Here, the model automatically will learn the features and classifies. So here the accuracy is unlimited. Here the accuracy is limited based on data set. Okay, now, so I have introduced you what is deep learning. We have seen that how we talk about starting with AI and then we ended up with deep learning. So this slide, it's a deviating slide, shows the importance of deep learning or machine learning skills. Top 20 emerging jobs. If you see that, this is a little old slide, but still this is a numbers are more. If you see that first two are associated with the deep learning, data scientist or machine learning engineer, they are occupying the first two places. Top job roles of CSIT. So machine learning and data scientist. So this is a old slide of 18 slide. But now also, but the same trend is happening. So the top emerging jobs, if you see that AI, machine learning, data analyst, everywhere you want a deep learning skills. Declining jobs also, we should see that we should not enter into that field. Data entry, you can automate the data entry process easily. So accounting, so account auditors also, the future. I mean, it's expected into 18, but maybe it's delayed, maybe 2026 and all. A machine or software will do automatically the auditing process. So that's what people are expecting. So the auditor is going to be a jobless in future. So deep learning at Google. So when you say the deep learning, the popularity of the deep learning and then the power of deep learning performance or whatever. The best example is Google products. So can anyone say that uh, the products where Google is using deep learning? Participants, can you mention the products? Which product Google is using deep learning? Any idea about that? There is not. We cannot. The simple thing is actually we can say that every product in Google is comes with a deep learning or AI. The popularity of Google products now. So why we are using Gmail? So suppose 100 participants are there. If I ask, I'm sure that 98% people are having Gmail account. 95% of the people will depend on Google search engine. 85% of the people will depend on Android mobiles, right? So Google is everywhere now. So Google is going to soon Google is going to rule the world. The main reason behind that is actually they started AI or deep learning projects a little bit earlier compared to the other companies. See, for example, 12 itself they started AI projects. So AI project means whatever software project they are doing, they involve the AI technology. Initially only 50, around 50. Slowly they improved from 50 to 350, 350, 1300. 2015 they reached 2700. Now if we ask that the all the software projects, whatever they are developing, whatever they are involving, everywhere the deep learning will be there. So this is a one important reason. As they started these things earlier, they are getting better performance now. It's not like Google search engine is improved in a day. You may look like a Gmail is improving. Gmail, the how the Gmail is improved recently. If you see that, it's suggesting a sentences for you, right? If when you say hello, it will say that hi. If you say that, it will say sir or ma'am or the particular name of the person, first name of the person. It's a predicting that. So everything it's not comes in a one day, right? So it's based on the 5-year research or 5-year data, whatever they have built and then they develop the customized for the user. So Elon Musk, you guys know the popular guy, so the multimillionaire. So he made the statement. He said that he's saying that I am only afraid of Google. He's telling that he is only afraid of Google. So the meaning is the future he is talking. So because the Google occupies everything. So you just think that without using Google product, can we live for a day? Now that now it's a reason it's not possible. Soon Google may come up with a model like if you are using more than 50 Google search, so you have to pay. Chances are there, right? So now itself they have some product, or even if you want to increase the space of Gmail, you have to pay. So whatever you are having is a limited access now. So soon everywhere they will start they'll try to make money out of it. Fine. That's a statement by Elon Musk. So when it comes to, again, we'll come to that machine learning. So we have seen that we defined the machine learning. If you see that the machine learning is associated with not a single domain, it associated with statistics, evolutionary models, decision theory, cognitive science, database systems, information theory. So all fields are combined and then form the field called the machine learning. Why now the deep learning or AI is popular? The next question. Why not earlier? Why now that deep learning? We can see that. even the machine learning was there. Why now? The first reason, if you see that the amount of data available. So we have a huge amount of data available. So the recent statistics says that the 80% of the data, whatever we are having now, is generated in last few years. The data is improving exponentially. And we have a good computational power. Soon we are going to see the smartphones with the GPUs. Now we don't need to worry about buying GPU. We are using cloud GPUs. So computational power also, we have enough computational power. So other important point is growing progress in available algorithms. Daily new algorithms are coming with a source code in GitHub. It's coming. So you don't need to start anything from scratch. New algorithms are coming daily. You can apply the new algorithm to your model, your domain. That's enough. So growing progress of new algorithms. Increasing support from industry, that is other important. So industry support, so the product, so they want to use AI in everywhere. They want to use deep learning in their products. So definitely they are supporting that. So the other point I can say that now the academy also started working on deep learning and AI. This is the main types of machine learning. So the one is classical, I can say the classical machine learning model, reinforcement learning model, and neural network or deep learning model. So can anyone say that what is mean by supervised learning? Participants, what is supervised learning? The next one we are going to see about that, right? What is supervised learning? Participants, what is mean by supervised learning?
Machine can train.
That is machine learning. Supervised learning means?
Some maybe some known task.
Known task. Okay, any other words? Any other answers? Supervised
Yeah,
learning.
sir.
Yes, ma'am.
Yeah, working on structured data.
Structured data. Only structured data. Unstructured data also we can
Labeled
use in
data.
supervised learning. Labeled data, yes. So
Label
if I say my X is my data and I have something called a label Y, that is supervised learning. X means, as I said, that the images are X. Y is, I'm telling that this image is cat, this image is dog, this image is not cat, this image is not dog. That is my Y. So I'm teaching machine, like how you are teaching the kid. You are showing the apple image to the kid and then you are telling that this is apple. You are telling that, right? This is apple and then you are showing the image. That is supervised learning. With the supervision of you, it is learning, like a machine is learning with your supervision. Y is called the classes or labels. This is a supervision. The other one is unsupervised learning. Only X is given. I'm only giving the images to you, but I want to know that whether cat is there or not. So model will do the clustering. It's unsupervised learning. So I'm only showing the image to that. The kid doesn't know anything about apple or orange. But I'm just showing, I'm putting some 10 images to my kid and then I'm telling that, can you arrange that apple images separately? Can you arrange orange images separately? But kid doesn't have any idea about what is orange, what is apple. But what a kid can do is, based on the similarity kid can do, right? Okay, this is also red color and this is also red color. So both are maybe, kid doesn't know whether it's apple or orange. So it can put it in the same basket. Another part, this also this is also orange color, this is also orange color. These two are maybe the similar group, look like a something. So same basket. Shape, this is look like a similar to the whatever I put in this basket. So something like that is unsupervised learning. Without your supervision, you are not teaching anything to the machine, to the kid. You are giving data, 50 images you are giving. You are asking kid to segregate that. That is unsupervised learning. X only you are giving data. So there is other model called, there is no Y here. There is no Y. So Y, no Y. There is other model. There is no X, no Y. It is called reinforcement learning. There is no data involved. There is no labels, no data. It's purely based on environment. So we are creating environment. Say for example, playing a game. If I ask you to create, if I ask you to come up with a something, if I ask you to come up with how you are playing the game, if I ask you to come up with some model, some data, we cannot say that. We know that how we are playing, right? I cannot give you data on it. Say for example, you are riding a cycle. Now I am telling that. Can you give a data for that? So I'll just train a machine learning, then I'll just make my robot to learn cycle. We cannot tell, right? So only thing is we have to like how you trained, how you learned then cycle, whether you someone shown the image to you and then someone teaching you, someone taught you that this is this image wise, it's fine. Learning the cycle is it's a practice, like some environment, some experience. 2-3 times you fell down, so someone is supporting you and then someone is saying this is right, this is wrong, and you are learning. Same thing I'm going to do the machine. That's called reinforcement learning. If machine is doing right, I'm saying that I'm appreciating, I'm patting, I'm saying, yeah, you are right, I'm rewarding. If it's doing something wrong, I'm just saying that I'm giving negative reward. That is reinforcement learning. There is no X, no Y, environment based learning. Fine. So now, when it comes to that, as I said that the data, huge amount of data is available. So data can be in any form. Data can be text, data can be signal, data can be image, data can be video. So data can be a protein structure. So anything you can say that it's a data, or the legal documents or the medical images. So the discharge summary of 1,000 patient, everything is data here. Fine. So this is a Google trend with respect to deep learning. So 2017 itself, it reached the 100%. So more number of people started using deep learning models compared to other machine learning models. This is an interesting competition called ImageNet, where over the period of year from 2010 to 15, we see closely that the deep learning models are giving highest performance. This is the error rate. So earlier the error rate is 28.2. Deep learning model reduce the error rate to 3.57. This is the proof for the performance of deep learning models as well as the importance of that. Okay, before going to see that why deep learning or what exactly deep learning, I have some questions in my mind. I'll just ask that. So we are talking about something called machine learning, right? So you are defined the machine learning perfectly. Someone defined that. So machine learning, right? So now we already know something called programming, right? So can you just compare these two things, programming and machine learning? Participants, can you just compare programming and machine learning? Because this is going to say about why deep learning or why machine learning. Why not programming or why not existing models? That's the question. Why I should go for deep learning or machine learning? I have something called programming, right? Participants, quick answers.
Sir, in programming, we need to give the instructions to the computer.
We need to give instruction to the computer. Yes, ma'am, right?
But in machine learning, in machine learning, the computer itself will create its own set of instructions based on the data.
So you mean to say that the computer is creating the instruction based on the data. You are giving only data, and then from the data, it's giving the instruction.
It will,
fine. So I agree with you. Any other? We'll
yes,
see
sir,
that.
we need to give the.
This is the one difference we can say. The instructions. Okay, data from data, it's going instruction. It's doing fine. Any other? I have something in my mind actually. One important difference. Machine learning and programming. So in terms of input and output, what is the input to the programming? You have a program. What you are giving as an input to the program? What is output? to the program? What is input to the machine learning model?
Data will be the input and the data will be the output.
Where, ma'am? And in a programming.
So the
Programming user gives the input.
in
Programming?
programming, data will be the input and data will be the output. Data
So,
will be the input, sir.
say
And
I'll
data will
take
be
a
the output.
programming. I'll take a programming. Say for example, factorial is a programming. You are giving A as a input, and then
Yes,
you are
sir.
getting a factorial of A is output, right?
Yes,
This
sir. Yes, sir.
programming is a factorial program, right? If this is the case, you are getting factorial as output. Am I right, ma'am? So this is actually a factorial program. A you are giving, and then you are getting A factorial as output. So the factorial program is a set of instructions you have written. So you know how to calculate A factorial, or you know how to calculate factorial. So you are writing the instructions and then machine is doing that. Fine. What about machine learning?
In machine learning, we are giving the data as the input and we'll get the program as the output.
Data as the input, and then we
Coding
are
as
getting
output.
program as output. But instead of programming, I am saying something, right? Function. So in programming, if you
Yes,
say
sir.
that, I'll write here, A you are giving as an input to f of A, right? This f of A is you have written these
Yeah.
instructions, right? The machine is giving
Yes, sir.
f of A, right?
Yes, sir. Yes, sir.
This f function is you have written, you are defining, you converted that into instruction. You know how to do the factorial, so you are doing that.
Yes,
Suppose
sir.
you don't know how to do, say for example, I'll say some geometric series. You don't know what is geometric series. I'm saying the example, man. You don't know how to what is geometric series. Can you do this programming for that? You cannot, right? First, you
Yes,
should
sir.
know the things, then only you can convert into your programming. It's fine.
Yes, sir.
But in case of machine learning, as you said that this is the input I'm saying, and this is the output. What is the input to the machine learning now? I'm drawing here the machine learning block. What is the input to the machine learning block? Instead of data, can you say in terms of A or f of A or function, input, output, like that?
A will be the input and
A
f
will be
of
the
A will be
input.
f
That
of
is
A will be the
programming.
output.
Programming is doing that. Then there is no difference, right? Programming also f of A is output. Machine learning also f of A is output. What is input to machine learning and output?
In machine learning,
Yes.
both A and f of A is also as the input.
Yeah. A and f of A is the input to machine learning. What is output, sir, then?
The output is a data.
Data you are giving input, sir. A and f of A both are data. Say for example 5 factorial is 120. I'm giving 5 and 520. 4 and 4 factorial is 16, right? 4 factorial and 4 threes are 12, 24. 24.
The main difference for machine learning is function is also already created. They taken as do the operation and get
So
the output.
the difference we have the difference, I asked the question, but I just taken in a different way. You understand the programming, right? Input is A.
Yes.
We have a function f, and then we are calculating f of A. Three terms: A, f of A. So machine learning, A
In
we are giving
program
and f of A we are giving.
user only defined.
Yeah, that
But
f of A
in
is
machine learning already generated in machine learning. So the output is also a data.
okay. Output is, so
Clear, sir?
input is A, input is f of A. Machine learning. What is output?
Machine learning.
So based on the output, it will based on the function, it will decide the algorithm, sir.
Based on the function. So it knows the meaning of the function. It knows the value of the function, right?
Yes,
A.
yes, sir.
So we
The
have only
output
three
value.
terms. A we have, f we have, f of A. A is given taken here, f of a is taken here. The machine learning output is actually
Yes.
f, the function.
Yes, sir. Function.
So the instruction, whatever you said right initially, that is the function. It won't give the
Yes, sir.
programming as such. It will give a mathematical way of doing it. It will give a mathematical equation or something like that. Now,
Yes, yes,
it's
sir.
the right time to ask you guys a question. There is something called training and testing, right? Machine learning training and machine learning testing. Or machine learning or deep learning. What is the output of machine learning training? What is the output of machine learning testing? Some disturbance from sir, can you mute? Hello. Yeah, please. Yeah, thank you. So what is the machine learning training? What is the output of machine learning training? What is the output of machine learning testing? Participants, am I audible? Yeah, I'm audible, right?
Yes, sir.
Okay.
Audible, sir.
Yeah, thank you, sir. So what is that? What is that machine learning training output? Machine learning or deep learning? Quick answer. So machine learning training, you guys know about training, right? Machine learning training. What is the output of machine learning training? Hello?
Used for machine learning training is only used for deep learning process. Only
Yeah.
going to continuously study the process of work.
Okay, sir. What is the output, sir? What is the
Testing is
physical output? Physical output.
whether it is
So the output of the machine learning training is actually something called a model or a function. So the model consists of a mathematical parameters. So simply saying weights and bias. So this is the machine learning training. You can see here, whatever I explained here is a machine learning training. You are giving a data, you are giving labels, you are getting some model. How the data is mapped to this f of a. How the a is changed to f of a. So the input and output, the machine learning is doing a kind of mapping, right? So input is mapped to the output. How it's doing this mapping? The mapping is this function. So this is called machine learning model. Fine. So this is true for deep learning also. So when it comes to the deep learning, so as I said that how the deep learning also, it's similar way, it's mimicking the brain behavior, how your brain understands the images. Say for example, how you understand if even though if you are seeing only the one small part of the car, and you can say that it's car. So your brain stores the car image in a hierarchical way. The small objects are stored. The same way, the deep learning also trying to understand small piece of information with the help of several layers. So that's what we are calling it as a deep layer. So it's a hierarchical of layers. So here, one more question, one final thing regarding the machine learning and the programming. So we cannot solve certain problem with the help of programming. Because as I said that the factorial, you are solving the problem factorial. You know how to do factorial. You are mathematically, you are deriving it and then you are doing. Certain things, you know how to do it, but you cannot express. I'm asking, how you know that this particular person is, say for example, India map is there. How you know that that is India map? Can you write a code to understand this India? If I give the images of a different country maps, your model should understand that it's which is India. Can we write a program to solve that? We cannot write, because we know that this is India, but we cannot write a program to solve that. It means that we cannot describe mathematically. So we need some algorithm to describe mathematically. That's what we are taking a help of machine learning. So machine learning will describe that things mathematically. Machine learning or deep learning. So you want to understand the India image, right? So you give India images, you give 50 India images, I'll learn from it. So next time when you are showing some image, I'll say whether it's India is there or not. That's what the machine learning will do, instead of asking a program to solve that. Fine, that's a difference between programming. That's the reason we are going for machine learning or deep learning. Fine. So now, so far I just started with a what is AI. We have seen about AI. We have seen the machine learning introduction also. I talked about supervised, unsupervised, and then I have covered deep learning also. Now, the types of machine learning, if you see that where the deep learning is, the major type is a deep learning, one major type, neural net and deep learning. The deep learning architectures, or if you see that the popular architectures, I'm not covering the architectures now, so I'll just directly go to the application. But the popular architectures are convolution neural network and recurrent neural network and generative adversarial models. And the final one, you can say the autoencoders also. These four are the popular architectures of neural network. CNN widely used in image processing problem. Recurrent neural networks are widely used in sequence problems. If your data is consist of sequence information, you can use recurrent neural networks. Generative adversarial network is a GAN. So if you want to generate something, if you want to generate the image, if you want to regenerate something, if you want to generate the text, you can use a GAN and autoencoders. So that's what as I said, that the convolution. So one slide I'll just explain about the convolution. You can see here, then we'll quickly go to the applications. So convolution neural network, what is happening is you have an input and we have something called a kernel. The simple convolution operation is happening here, like we are multiplying A and W and B and X, E, Y, F, Z. So we are doing that. This is a 2D convolution. So the simple way of understanding the convolution neural network is, you assume that you are in a room where there is no light, but in the wall some picture is drawn. I have drawn some picture. Say for example, I'm drawing some car picture. Okay, fine. So you are in a room, so there is a picture, no light, you don't know what is there in the picture. But now I'm asking you that you cannot see that screen, you cannot see the wall as it is completely dark. Now I'm asking you to find out what is there, but you are asking some help. So I'm giving a torchlight to you to understand what it is. So what you will do, you will slide over the torch over the image, right? You slide over the torch to the image and then you will try to understand. So the small pieces of the information from here, it will record to your brain, and finally you will aggregate the information and then you will say that, yeah, this is a car. So for identifying this one, you don't want a bigger torch of same wall size, right? Even a small torch is enough to do that. Small torch. So small torch is enough. You don't want a bigger torch of the wall size. Use small torch is enough to understand that this is a car. So as I said that this small torch, this is how the CNN works. CNN, same way the CNN will record the information of the image. It will store this information from the pieces, segmenting the images will store as a piece of information with the help of kernels. The kernel is your torch. So preferably we'll go for a small kernel. W, X, and Y is your kernel. So the kernel information is stored. You are storing that information and then you are The model is understanding that. This is called convolution neural network. You can see here how the convolution is happening. So as we don't have much time, so I want to discuss about some application. So I'll just go to that next one. So this is how the neural networks, the basic neural networks. So we'll see about RNN now. Okay, fine. Yeah, sorry, I think I don't have the RNN slide. Fine, I'll explain that RNN in one slide. So now CNN, we have seen that CNN is for the image processing. So we are using some kernel and then we are using a torchlight to understand how we are understanding the image. Same way machine understands that. That's a concept of CNN. Other important algorithm, something called RNN, recurrent neural network. It's used for sequence learning problem. Sequence learning problem, say for example, if your data follows some order, say I'll just say some example for the data following some order. So your stock market data. So your 9 o'clock price, 9:10 price, 9:15 price, 9:20 price, 9:30 price, 9:40 price. It follows some order. So it's with respect to time, it's changing. So data changes with respect to time is also a sequence data. And other sequence data examples are protein sequence. There is no time involved, but the sequence is important. That order is important. NLP data, the other example. Say for example, I saw, I'll just write a sentence. I saw a cat on the mat. This order is important. I cannot rearrange it, right? I cannot say that cat, mat, a, saw, the, on, I. You won't understand anything. So the natural language, I should follow certain order. So now this is also an example. This is the example of sequence data. So if your data is in a sequence format, you can use the RNN model. So what the RNN will do is it will consider this as a sequence. It will try to learn I. From I, it will pass the information. It will learn saw. From saw, it will try to learn the information of A. It will learn the information of cat. It will learn the information of on. Learn the information of the. So like that. So this is a one directional. This is a, we can say that RNN. Bidirectional RNN is there. So where you can come in a reverse direction also, left to right and right to left. So you are learning the sequence such a way that so each and every unit and then the associated next unit you are learning and then you are proceeding like that. So this is a concept called recurrent neural network. Fine. Now we'll see some of the applications of deep learning. So we can see here there are some images of a man with glasses, right? With glasses. And here I don't have a man. I have a man images, but I don't have a glasses, without glasses. So I'm subtracting these two. The mathematical expression. Man with glasses minus man without glasses. So subtraction means a difference, right? So what is the difference here between these two images? You'll say that glass. So I got a glass actually, fine. So I'm doing addition. So I'm adding that glass with this person image. It means that what I'm expecting from the model is the person image, whatever is given here. So I'm going to add glass to the person. So see here. This is the machine generated one. This is a machine generated one based on generative adversarial network. See how accurate it is. Can you believe that it's a human generated images? It's very difficult to understand human generated images, right? So see how the machine is generated perfectly. It's artificial image. So like there's so many applications. I don't want to list out the application. As I said that wherever you are having the data, you can apply deep learning models. So the other application, if you say that duplicate image identification. So this you guys know about the image search. So if you give the text Taj Mahal, the machine will identify, the machine will extract the Taj Mahal the reverse way. If you paste the image, you don't know which place it is. You are pasting the image. There is option of image search. If you're pasting the image, the model will automatically say that where this place is. It's something called, say, a duplicate image understanding or a similar image understanding. So if you give one image, it will find out all the similar images of that. So other interesting task is visual question answering, where you are combining natural language processing plus computer vision. You can see here. So the image is given, but I am asking a question with this. My question is, how many horses are in the image? So the input is image plus question. So the output is answer. The answer is output. The answer should be 2. So the question is, how many horses are in this image? Or I'm asking something, how many? What is the? I'll ask that how many persons are there in the image, or I can ask that what is the color of the first horse, what is the color of the second horse, something. This is called visual question answering. This is also interesting applications. And something the recent deep learning algorithms are doing that actually is automatic colorization of black and white images. So you can pause this image, automatically machine will give the colored image. So automatically it's based on deep learning. Earlier it's based on the computational photography. Now it's based on the deep learning is giving that. So in computational photography also we need to choose the colors, but now you don't need to worry about the colors. Automatically deep learning models identifies the scenario from the image and it gives its color. These are the popular frameworks, or these are the popular tools available for deep learning. So on machine learning, start from Veka and sklearn, libsvm. So all the scikit-learn package. So all these things are popular tools or frameworks, and other things are like a recent TensorFlow, PyTorch also you can use. Fine. So when it comes to that, the other applications, so the major applications I'll discuss now. So you can see here there are a lot of applications. I have given a 20 applications. As we don't have much time, so I'll take a 15 more minutes and then I'll just explain some of the applications. Say for example, in natural language processing, so identifying the fake news or fraud news, it's a deep learning application. And detecting the development delay in children based on their essay writing, based on their social media conversation. So you are finding the developmental delay in children. It's a deep learning application. And colorization, we have seen that. And other interesting application, if you see that, adding sound to the silent movies. Automatically you can add sound to the silent movies. It's also a deep learning application. And healthcare, there are a lot of applications happening in the healthcare. Healthcare with respect to text, healthcare with respect to handwritten recognition, healthcare with respect to images, healthcare with respect to radiology images, healthcare with respect to signals in terms of heart signals or the BP or whatever the signals you are taking, and then you are analyzing that whether the person is having the heart attack or not. That is also comes under healthcare applications. Automatic machine translation system, converting a language, one language to other language. So I need to convert whatever I'm talking need to be converted into Chinese, or you want to convert whatever I'm telling in a Telugu language. It's automatic machine translation. Automatic handwritten generation. So that is a, you want to write, you want to email. The future email will be like that. You want to email to your to the persons like how your real handwriting like that. There will be automatically, if you are feeding your 10 or 20 handwritten examples, the model will generate the font and then it will give you a font. If you install the font to your system, if you select the font, whenever you are emailing me or you are emailing anyone, so I can read your email in your own handwriting. So even you can write the recent song you can take, and then you can see that how the earlier persons, or say for example how the person, some person may not be available now, But if their handwritten things or scripts are available, you can generate their handwriting for the new songs, something like that. So, and the other interesting thing is deep dreaming. So now the researchers are doing some research on identifying or recording your dreams. So automatically how to record your dreams. So they may place some chips on you, because now the main problem is each and every day we forgot that what we'll, some things only we'll remember, we won't remember what are the dreams comes. So the psychiatrist says that the dreams are more involved in because each and every dream whatever you are having is there its own reason. So it can help you to predict the future, because the dream may not happen as such, but it's going to give some clue to your life. So people try to record the dreams nowadays. So that comes under the deep dreaming with the help of deep learning. So this is the image translation. You can see the image translation example, like I have a text, I have an image, the different language. If I'm translating, I'm getting dark image Excel cookies, the real-time translation. Suppose I'm visiting Hyderabad, so I don't know Telugu to read. I'm taking a photo in my using my mobile phone. Automatically, it's converting into Tamil or English or some other languages. So this is the example, as I said, that the YouTube link is given. So adding sounds to the video frames. There are a lot of applications here, because we know that a lot of CCTV images are there. There is no sound option in CCTV images, but based on the situation in the CCTV images, you can generate the sound automatically with the help of deep learning. So this is a little old research, but that the video is available. It's a research from MIT. YouTube link also available. Have a look onto it. So the object identification. So a model can understand your face, facial emotion, or you can understand your age group, gender, whether you are male or female, what's your age group, whether you are African or you are Asian or you are American. So things can be understood with the help of deep learning model. So this is a little word slide. So it talks about Amazon Echo. We know the Alexa. So Alexa daily, the Alexa is improving. So the Indian language Alexas are going to come, and you can train Alexa in your own language or your own accent also. So Alexa may speak like how your wife is speaking in future. So same thing like a the Alexa, the Google product is a Google Pixel Buds or Google Glass. So with the systems are now, everything is based on the deep learning model. It's already supporting more than 60, 70 languages. With respect to, particularly with respect to healthcare, if you see that, so people are giving importance to the potential annual value in 2026. People are predicting that robot assisted surgery is the, so we are seeing the memes, or we are seeing that we are getting the images in WhatsApp, right? So there are, recently I got some message. So people, the doctors undergone 36 hours continuous surgery, brain surgery. See that 36 hours continuously. So it's very difficult for us to, without sleep, 36 hours continuously, 2 doctors. So how can you imagine that? So there are high chance for the doctor to made a mistake during after 20 years or 30 after a few hours, because definitely their energy is drained, and then they cannot they made high chance for them to make a wrong decision or something. So how to avoid that? How can we introduce robot to assist in the surgery during these things? Visual nursing assistant, the other important area where you can concentrate. So administrative workflow in particularly in healthcare systems, fraud detection with respect to healthcare, dosage error, automatically identifying the dosage and then finding the errors, and the connected machines. So how to say for example, when you are taking some values, some experiments, you have to do that. You have to connect the machines to the persons and other things, right? So how can we improve it with the help of AI? So instead of wire, how can I make it some kind of wireless chips? Or how can you make a smartphone to take this clinical information or clinical experiments? So this is again the machine learning with the healthcare, the medical imaging. So as I said, the visual question answering. So you can show the radiology images to the machine. Machine will say that whether the person is having COVID or not. And you can ask the machine why you are telling that it's a COVID. Machine can underline that this is the portion where his lungs is more affected. That's the reason I'm telling that it's a COVID. Some inference from there. It's also possible. Other application with respect to healthcare, there is a hackathon data set is available. So you can predict the doctor consultation fee. It's a hackathon is there for doing that. So it's not in Indian context, it's in a US context. So, but there are a lot of applications here. It can be used for insurance company. So based on this doctor's fee, they can, based on your location, they can fix your premium, medical premium instead of fixing for all citizens. So based on your location, based on your doctors, nearby doctors, I can fix. So other application with respect to corona or this, I mean the coronavirus, there are a lot of research articles available, the whole research articles. So the link is given here. The Allen Institute of IT, the Allen Institute of AI releases this data set, open research data set, near 36,000 research articles with respect to coronavirus. So remember, this data set is in 2019, it's released. It's an old data set. So that can be used to identify that COVID fake news or any rumors from the COVID related to the COVID is there, then you can predict that based on this information. So there is something called IEEE data port also, where you'll get some data set related to coronavirus feed data set is available. These are the some of the competitions we are organizing. So for getting the data set, and then you can apply deep learning model. This is with respect to natural language processing. So we are calling it as a code mix, Dravidian code mix. This is a recent one what we are organizing. So like this, there are a lot of data sets that are available. This is the data set talks about whether this particular tweet is informative or not. It's related to COVID-19. Data set is also available, the link. Anyway, I'll share my slides. You can make use of it. This is also a data set. Fine. So we are coming to that final slide. So before final slide, so this is the interesting slide, talks about all deep learning networks. So you can see here that deep convolution network, all the networks are given, and then the explanation is given. Detail it's given. So for you, it will be a better understanding of all networks. You can easily understand the network. You can compare the networks with other networks also. So with this, I have given some of the links, web links, where I have taken this, and then where the more resources about the deep learning. So please make use of it. So with this, I'll just stop my presentation. So now we have 5 more minutes, I guess, or 5 or 6 more minutes. So it's for a question answering. If you have any questions, you can ask me now. Yeah. So thank you, participant, once again for actively listening my lecture. So now we'll have a discussion. If you have any questions, please feel free to ask. Anyway, I'll give my email address also. If you want any details about the algorithms or data set, you can ask me. But if you're asking now, I'll immediately respond. But if you are emailing me, it may, as usually, I'll be busy. I'll take some time for me to respond.
Thank you very much, sir.
Yeah, thank you, sir. This is my email ID is given.
Sir, email ID given as
yeah, I just posted in a chat box and chat, sir. Actually.
Okay.
Dear participant, if you have any queries, please ask to sir. Sorry, on the line.
No doubts? No clarifications?
No clarification, sir. Which is clear.
Okay. So anything else, sir? Muruga Muthu Gurunathan, sir.
No, sir. I am Dr. Jagadeesan, sir. Sir.
Okay, Jagadeesan, sir.
I am
Okay,
the
yeah,
master
Jagadeesan,
class,
sir is
sir.
also there. Yeah.
Thank you very much, sir.
Thank you, sir. Thank you, participants. Thank you for your invite, sir.
For your more contribution for today. You have the more busy schedule, but giving chances to our college. Thank you very much, sir.
Thank you, sir. Please share my email address to participants. If you have any clarification or anything, please feel ask them to contact me. I'll help them. How much I can possible.
I will share.
Yeah.
Share.
Thank you,
Okay,
participants, and then thank you, sir, once again. Thank you all.
Dear participant, I posted a today feedback link. Please fill the feedback link and get from the rooms.